Hello guys, welcome to this video. My name is Phani and I am a data engineer based out of India. So today I'm going to discuss about a common scenario which we face in most of the data engineering projects and data engineering workflows, and how we can solve this in a better way. Okay. So the problem here is in most of the scenarios we will have a table or a job which is dependent on n number of tables and jobs. Let's say for example, here in this case there is this final table which is dependent on table 1, table 2 and table 3. And if you see, these three will run at different intervals. Okay, so these final tables should be loaded after completion of table 1 and 2 and 3, right? So this can be solved in Airflow by using external task sensor, which will check for a it will check for execution of a given task in a DAG, and if it's executed successfully, then it will trigger the next task. Okay, so that's how external task sensor works. But the drawbacks of that is you should have a time interval where your tag will start, and it will keep on polling and checking for the status of these three tables. Okay, this means you need to start at a particular point and keep on waiting for something to happen, or these things to turn green, right? So this way there will be unnecessary compute usage, and then unnecessary billing as well, right? We can solve this problem very effectively if this is an event based approach. Let's say table 1 has loaded, table 2 has loaded, and table 3 has loaded. So when this table, last table or whatever the table which will load last after completion of that, if you could trigger your final table, that means you can just simply start the final job as soon as all your dependencies met. You don't need to start your job and keep on polling and waiting for something to happen, right? So let's look into that, like how we can solve this problem using event based approach. Okay, so in order to solve this problem, we'll be focusing on two things mainly. One is events and another one is state store. Okay, the events are, let's say for example, whatever happens on a BigQuery table, a insert operation or a delete operation or update operation, anything that happens on a BigQuery table, so that will be logged into cloud logging as an audit log. Okay, in our case, we are considering this insert job because that means whenever something you write something into BigQuery table, insert job gets created. Okay, so we are going to consider insert job as our event. So what we are going to do is we are going to consider that insert job as an event. When that event occurs, we will do something that I'll come to that later. And coming to state store, our state store has three tables: metadata table, schedule queue table, and history table. Metadata table has the DAG IDs and the tables which the DAG is dependent on. Let's say our final table DAG is dependent on table 1, table 2, table 3. So metadata contains these configurations. And schedule queue consists like based on the event that got generated, schedule queue gets updated, like what DAG should be triggered next, or what is the status of a particular DAG. Let's say table 1 got loaded, you will have the event generated, right? So what it will do is it will go and check in the metadata that what are the DAGs which are dependent on table 1. In my case, final table is dependent on table 1, right? So what it will do is it will insert the dependencies of that DAG, and it will mark this table 1 as done. That means like you I'll just come to the table structure and data. So that means it will just mark the status. It will only store the state of the table 1, and it won't do anything. Okay, this history is like once your DAG gets completed, we will remove it from the queue and we will move it to the history table for audit purpose. Okay, so how we are going to do it? I'll show you the architecture. Okay, so here there are two flows. So first let's focus on the first flow. That is, as I mentioned, like you will have the audit logs in cloud logging, right? Let's say some one of the table 1 got loaded. What happens is you will get one log, and that log will be streamed into PubSub as a sync. So you are going to configure PubSub as a sync, and this message, whatever the event that has happened, that will be streamed to PubSub. Now what PubSub will do is PubSub will trigger a cloud function. PubSub will trigger the cloud function. Cloud function will take that log message which is received from PubSub, and it will trigger your scheduler DAG. Okay, scheduler DAG is the main thing here. So what scheduler DAG will do is scheduler DAG will take the metadata from your PubSub, and it will update the dependency queue by checking with the dependency metadata. So it will check Okay, now I got event for table one. So what should be the next course of action? So it should check the dependencies and it should update the queue. So that is what scheduler DAG will do. Once updating the queue, next it will check what DAGs it can trigger. Is any DAG ready for getting triggered? So it just checks those DAGs which are ready to trigger. If there is a DAG which has all dependencies met, it will trigger. Okay, it will trigger the target DAG. Okay, so this is the flow, and there is one more flow. If you see from the beginning, I keep on talking the dependency metadata table, right? Like how you are going to configure this DAG using BigQuery tables. Okay, I'll show you an example here. Test DAG, it does nothing, just is a dummy task. Okay, here I have done is in my Python file, the DAG file. What I have done is I have created one magic variable called BigQ table dependencies, and I have passed the list of tables which my DAG is dependent on. That's it. This is what all you have to do. Once you done this, this file will be uploaded in your DAGs folder. So once you upload your file in your DAG folder, your cloud function gets triggered and it will read your DAG code, the Python file which you have uploaded. It will read that code and it will find out the dependencies based on the magic variables, and it will insert those dependencies into your metadata table. Okay, so that is how you will your dependencies will be maintained in the metadata table. Okay, so let's have a look at the metadata table. You can see that there is one entry for this external custom task sensor. So I just remove it so that I could see a fresh demo. Okay, so everything got removed from my metadata. I'll just show you once again. Okay, so now I have added my dependencies here. I'll save this file. Then I will upload this in my DAGs folder. So now I have uploaded my DAG. It's updating the dependencies and it has updated the dependency. Let me just check once. Okay, right. Like you can see, right? This DAG ID is dependent on these two tables. Again, this record last got modified at this time. Okay, so this is just for audit purpose. Okay, now what should happen? Let's say table one, test one got loaded, but test two didn't got loaded. In this case, my test custom external task sensor should not be triggered. Only when these two triggered, then only my external task sensor DAG should get triggered, right? So let's test this scenario. So as of now, what I'll do is I'll try to generate one event into my PubSub, like how cloud logging does. I'll have the same metadata, but I have custom code to do it because of some access issues. I'll just try to publish the message into PubSub. The same. Okay. So yeah, let me reconnect to my shell. Okay, now I just authorize. Okay. So now one log entry has been routed to PubSub. This means it should trigger my function. Ideally, this function should trigger my DAG. Okay. So as you can see, it has triggered my DAG. Now let me check my DAG. The DAG is already running. That means that event which got published into PubSub topic has triggered this DAG. So let's check the logs. Yeah. Here you can see that DAG was triggered by the table test2. Because of this table event, this DAG got triggered. Okay, so what this will do is this DAG, I'll just show you on high level. So it has basically two Python operators. This one is dummy. So what one task will update the queue and another one will pick up from queue which is ready to be triggered. Okay, so if I check my meta queue, like whether is anything ready to be scheduled, like if you see here DAX to be triggered is none. That means no DAX to be triggered. Why? Because if you see custom task external sensor has two dependencies. One is completed. Test 2 is completed, but test 1 is still waiting. That's why it didn't trigger my DAG. Okay, so here you can see just three greens. Okay, so if I show you my BigQuery meta queue as well, uh, yeah, here you could see that this task has these two waiting. This this DAG has these two tables which it is dependent on, and you can see one of them is completed and one of them is waiting. So that's why DAG status is queued. Okay, now let's do one thing. Let's try to generate event for other table as well. That is test one table. Okay, so this means all the dependencies will get successfully met, and this DAG should start running. The other DAG should start running. Okay. Yes, you can see, right? So I just generated event for table one, and it in turn triggered the cloud function, and cloud function triggered my DAG. Okay. Yeah, let's see. Okay. Okay. So now everything got completed. So that's why you won't find anything here. It will be moved to the other one. So now everything got completed. Now if I refresh, that since it got removed from queue, it will be moved into the history table. Now if I show you the target DAG which should be triggered, if I refresh this, then I should have 4 green because I should have one more extra one. Right? You could see which got triggered at 12:44. If I see my scheduler DAG when it ran, I can prove you that these two ran at the same time. Okay, you see 12:44. The other one is like 12:44:09. This is 12:44:11. The same time. Okay, this likewise you can configure n number of dependencies on your table. So this is how this can be done. Yeah, that's it for the video. Like if you have any queries, you can reach out to me on my LinkedIn. I'll attach the link in the description. Okay, thank you.